Welcome to today's video class. We are going to be talking about initial value problems. So we have two questions here on initial value problems, two problems of initial values, where we have to solve these ODEs using these initial values that we given. So for the first equation, we have y double prime. I'm not supposed to write but for the sake of y prime plus 3y equals to 0. This is a linear and it is homogeneous ODE. It's a linear second order homogeneous ODE. So we use substitution, let y equals to e raised to power rx, which means our y prime will be what? Rx, and our y double prime will be r squared ERX. So without using all this, we can easily write out our characteristic solution as r squared minus 4r plus 3 equals to 0. So solving this, we have minus 3 minus 1. R minus 3 minus 1, if we r minus 3 r minus 1, if we factorize, we get this r squared minus 3r minus 1 gives us this 3 times 1 is 3 minus 3 times minus 1 is plus 3. So we have our r equals to 3 or 1, which means our y1 equals to c1 e raised to power the first one x, 1x is x, or c2 y2 equals to c2 e raised to power the second one 3x. So these are the two solutions we get for this ODE. So our y equals to y1 plus y2, right? So it means our y equals to c1 e raised to power x plus c2 e raised to power 3x. So we are getting our complementary solution. This is our complementary solution. So the main point about initial value problems is that we have been given these two sets of initial values so as to remove our constant from this solution. So as to remove this constant from this solution, we have solved for the solution of the ODE. Right there. Now let's write it out. So we have y equals to c1 e raised to power x plus c2 e raised to power 3x. Now let us rewrite this using our initial value problem. Our initial value. So these initial values, what they do is that they help us eliminate C1 and C2. Now let us work with this. Using this, y equals y of, the meaning of this is that y of x equals to, let's say, another value equals to y itself, y not, or whatever. So it means whenever x is this value, y is this value. So from here we have y of 0 equals to minus 1. So it means whenever x is equal to 0, y is equal to minus 1. So that's the meaning of this set. And this one we have y prime of 0 equals to 1, which means whenever x is equal to 0, y prime equals to 1. So that's the set of values they give us as the initial conditions. So what does this mean? This means, let us differentiate this first. Equals to, if we differentiate this, we have c1 e raised to power x plus, if we differentiate this, we have 3c2 e raised to power 3x. Now let's use these conditions. This first condition, we have to use it for this one. Y is equals to minus 1. Minus 1 equals to c1. What is e raised to power 0, right? X is 0. Plus c2 e raised to power 3 into bracket 0. So it means minus 1 equals to c1 e raised to power 0 is 1 plus c2 e raised to power 3 into 0 is also 1. So we have this first one, and this is our equation 1. This is our first equation. Now let's go to the second one. We have differentiated this using these initial values. Now we have y prime equals to 1 whenever x equals to 0. So y prime equals to 1 whenever x equals to 0 plus 3c2 e raised to power 3 into bracket 0. So we have 1 equals to c1 e raised to power 0 is 1 plus 3c2 e raised to power 3 times 0 is also 1. So this is our equation 2. Now for sake of space, let me remove this. So we have these two equations, equation 1 and equation 2. Equation 1 says c1 plus c2 equals to minus 1. Equation 2 says c1 plus 3c2 equals to 1. And those are the two equations we are going to solve simultaneously to obtain our constant. Now solving this system of simultaneous equation using elimination method, this C1 C1 we can easily subtract. subtracting c1 minus c is gone. So we have c2 minus 3c2 equals to minus 1 minus 1. So we have this is minus 2c2 equals to minus 2. Dividing both sides by minus 2, we have c2 equals to 1. Now we are going to substitute into equation 1 or 2. Let's substitute into equation 1. c1 plus c2 is 1 equals to minus 1, which means c1 equals to, when this comes to the other side, minus 1 equals to minus 2. So we have c1 equals to 1, c1 equals to minus 2, c2 equals to 1. So these are the constants, the values of the constants you have gotten. So we are going to go back to our initial solution. We are going to go back to our initial solution. The initial solution for this one was y equals to c1 e raised power x plus c2 e raised power 3x. This is the initial solution we got. So we are going to write it as y equals, what's our c1 now? c1 is minus 2 e raised power x plus what is c2? c2 is 1. So I write it as e raised power 3x. And this is the final solution for the ODE using these initial values. So that's how to solve initial value problems. Now let's use the second one. This is the solution for the first one. Let's look at the second one. Let's look at the second one. 2. Now writing this out as a characteristic equation, we have r squared minus 2r equals to 0. R squared, this is second derivative, so it's r squared minus 2r, this is the first derivative. So this is going to be the characteristic solution. So factorizing r, we have r into bracket r minus 2 equals to 0, which means r is either equal to 0 or r equals to 2. R equals to 0 or r minus 2 equals to 0, bringing it to the other side, we have r equals to 2. So it means our y1 equals to c1 e raised power r1x, and our y2 equals to c2 e raised power r2x. So this y1 will be equal to c1 e raised power, since is 0, that's 0x. This one will be equal to c2 e raised power r2 is 2x equals to e raised power 0x is 0. So this is 1. C1 times 1 is C1, and C2 is, okay, the same thing. So our y equals to C1 plus C2 e raised power 2x. So this is the initial, this is the general complementary. This is the complementary solution to our second ODE. Now we are going to find the value of C1 and C2 using the initial values we've been given. So using these initial values, we have y of 0 equals to 0 and y prime of 1 over 2 equals to e minus 1 equals to e minus 1. So we are going to differentiate this. Y prime, this y prime equals to, if we differentiate sigma is a constant, so it is going. If we differentiate this, we have 2 will come down, 2c2 e raised power 2x. This one left because it's a constant. If we differentiate the constant, we get 0. So y prime equals to this. So using the first set of values, it means when x equals to 0, y equals to 0. Now let's use this. Y equals to 0, 0 equals to c1 plus e plus c2 e raised power x is 0. 2 times 0 is 0. So it means 0 equals to c1 plus c2. So c1 plus c2 equals to 0. This is our first equation, equation 1. So this is our equation 1. To get equation 2, we use the derivative. Y prime, y equals to c1 plus c2 e raised power 2x, abi? Which means y prime equals to 2c2 e raised power 2x. Which means our y prime at this point equals to e minus 1. E minus 1 equals to 2c2 e raised power 2 into bracket. What's our x at this point? 1 over 2. What this one means is that y prime equals to e minus 1 when x equals to 1 over 2. So you substitute into this. So y prime is e minus 1 equals to 2c2 e raised power 2, x is 1 over 2. So it means e minus 1 equals to 2c2 e raised power 1. 2c2 raised to e raised power 1 is e. So this means we can write it as 2c2 e equals to e minus 1. I can divide through by e. So I have 2c2 equals to, if I divide everything by e, I will have 1 minus e minus 1, right? I can divide this by 2 too. C2 equals to 1 over 2 minus 1 over 2 e minus 1, which is the same thing as 1 over 2 into bracket 1 minus e minus 1. So we have gotten here now. So this will mean, since we have our C2 already, we have gotten our C2 already. C2 equals to 1 over 2 into bracket 1 minus e minus 1. It will mean C1. Don't forget, we have gotten our equation 1. This is equation 1. So we just substitute inside and say C1 equals to minus C2, right? So it means C1 equals to what? Minus 1 over 2 into bracket 1 minus e minus 1. That's our C1. We have our C2 here, but our initial solution, y was equal to C1 plus C2 e raised to power 2x, right? So what are we going to do? We are going to substitute C1 as this and C2 as this into this equation. So it means y equals to what? C1. C1 is minus 1 over 2 minus 1 over 2 into bracket 1 minus e minus 1 plus C2 is 1 over 2 okay, into bracket 1 minus e minus 1, everything times e raised to power 2x. E raised to power 2x. So it means I can multiply everything through by 2. 2y equals to minus, let me open this, minus 1 plus e minus 1. I've multiplied by 2 plus 2 plus 2. Okay, I'm multiplying 2 by 2, so this 2 is going to cancel out. Plus 1 minus e minus 1 e raised to power 2x. So if I open this bracket, I'm going to have 2y equals 1 plus minus 1 plus e minus 1 plus e raised to power 2x minus e minus 1 e raised to power 2x. If I add these two together, I'm going to have 2y equals to minus 1 plus e minus 1 plus e raised to power 2x minus e raised to power 2x minus 1. So the final equation for number 2, the final solution for number 2 is going to become 2y equals to, can I factorize anything here? Yes. Can I factorize anything here? No. So we are going to have something like e raised to power 2x minus e raised to power 2x minus 1 plus e raised to power minus 1 minus 1. And that's the solution to our ODE. And that's how to work with initial value problems. And that brings us to the end of this video. Make sure you like, share, and subscribe. Thank you.